Here we have two problems that are fairly typical of what you might see in the AP multiple choice section. One of these two statements that we have relates to a horizontal asymptote of f of x, and one relates to a vertical asymptote of f of x. Your job will be to identify which is the horizontal asymptote and which is the vertical asymptote, and also to write clearly and explicitly what the equation of the asymptote will be in either case. So there are a couple of things that give us a clue. When you have infinity out here on its own on the end, and let's see, it should be working now. Okay, when infinity is out here on its own in the end, that is an indication that you are dealing with a vertical asymptote. Okay, so this is a vertical asymptote. Now, vertical asymptotes are vertical lines, and vertical lines will always have the equation x equals something. Okay, x equals something. Well, it's very easy in this case. Whatever the x is comes from here. So when you see an infinity at the end of a limit statement like this, you know that you're talking about a vertical asymptote, and the equation of the vertical asymptote is simply given by what comes under the word lim. Okay? If you wanted an idea of what that would look like, the graph of that function would possibly look something like this. So let's say this is x equals 6. And we know the limit as x approaches 6 is going to infinity. So it's possible that the graph would look like this. And again, as you approach 6 from the right hand side, going off to infinity. Okay? So that's what it would look like. But the question that you're likely to be asked is to identify that this is a vertical asymptote. And you could be asked in a multiple choice question whether that indicates a horizontal asymptote, a vertical asymptote, the equation we're talking about here, this equation, whether that indicates a vertical asymptote, a horizontal asymptote, and what the equation of the asymptote should be. So the clue is that the infinity symbol on the end, on its own, indicates that you've got a vertical asymptote. Alright, let's look at this one down below. Here the infinity is part of the limit statement. Okay, the infinity is down there. Now, when you see the infinity down there, that indicates that you're dealing with a horizontal asymptote. Okay, and it could be infinity or it could be negative infinity. In either case, number 1 as well, it could have been negative infinity. But when the infinity symbol appears as part of the limit statement, so it's under the word limit, x is approaching infinity or negative infinity, then we've got a horizontal asymptote. Horizontal lines, the equation of horizontal line is always y equals something. And the something in this case is simply whatever is there, so negative 3. So we have y equals negative 3. And that is going to be the equation of the horizontal asymptote. So again, your task is to look at this and identify it as a horizontal asymptote and to give the equation of the horizontal asymptote. In this case, y equals 3 would be a line down here. Sorry, y equals negative 3. That would be negative 3. And we don't know exactly what this graph looks like, but it could be something like this. Okay, could be something like that. That's not a definitive answer. It could also be something like that, or it could be something entirely different. But we know that as you go off towards the right hand side of the screen, as you look towards the right hand side of this graph, that the graph should be settling around a height of negative 3. And that's just one possibility. There are various possibilities of what the rest of the graph could look like. It could also, we'll try another one, don't want to mess this up too much, but one last one that it could look like, it could be a damped trigonometry, sinusoidal form, which is crossing the line y equals negative 3, but settling down towards that line. Okay, hopefully that explains some of the types of problems you're going to see on limits of asymptotes.